Welcome to Expo Java Chapter 5, Control Structures. Today we'll be learning Part 4 of the chapter, Tracing Loops. In Chapter Progs, Java 0513.java is the 13th program in Chapter Progs. And if you can open that, you'll see the following code. You have main, which says the code within the two main curly braces will be executed when the main method is called. Then you have a print statement that will print the title of the program. Then you have a declaration. The declaration being K that sets up a place in memory and names it K, right? And there's no value initialized when K is declared on this line. Then you have a keyword for, and you haven't ever seen or used the keyword for before, but this is how it works. Use the word for in front of a conditional statement. The conditional statement has three parts, 1, 2, and 3. Whenever the loop executes, this control statement as a condition inside part 2 of the for condition allows for the code that is either blocked beneath the for loop to run or just a single line to run after the for loop is called. That's a short introduction. So first, let's go look at the anatomy of a for loop. The anatomy of a for loop. This is what we were just looking at, the actual code in the previous slide, but this is a breakdown of the parts of the for loop. Part 1 is used to initialize the counter. The counter in a for loop is called the loop control variable. The loop control variable is the first part in the parentheses where the condition for the for loop resides. So we have the keyword for, then we have part 1, which is your loop control variable. After the loop control variable, a semicolon separates part 2. Part 2 is a condition that as long as it is true, the loop will keep repeating. So the condition always tests some variable that will cause the loop to stop. When this condition is true, the loop will continue. When this condition is false, the loop will stop and continue to the end of the program. Part 3 indicates what the counter will be changed by. Now, part 3 in this loop changes by 1 every time the loop executes. So every time Eat It Joe's prints on the screen and goes back into the loop, K in memory will increment by 1. And then K will be compared whether it's less than or equal to a hard-coded value, 40, and whether this condition is true or false dictates whether Eat It Joe's Friendly Diner for the best lunch value will execute again. And that's an introduction to how a for loop works. Now what you are going to learn is how to trace through those values of a for loop. In this program, the only difference that I want you to note here is that K is not initialized outside of the loop. Remember that before in the last program, K was initialized here outside of the loop. Usually you want to initialize your loop control variable inside your for condition. So your counter needs to be an integer, needs to be an integer, and you declare it at the very first in part 1 of your for loop, just like you do in a declaration outside of the loop condition. Okay. This program, 0515, shows you the for condition, and then in the same way that we learned yesterday in part 3, is when you want more than one line of code to execute when the loop executes, all you do is block those statements together underneath the loop condition. Okay, so more than one line of code to execute when a loop executes, you just need to be sure and use your curly braces to block those statements together to have them repeat. Now this is what this program looks like when it runs, and we're getting ready to figure out, while being the compiler, how this works, and it's called tracing through the program. And we're going to run through this one also and see how the program, how these lines of code come up with these individual outputs. Before we start, let's look at the syntax and structure of a for loop. Java has a variety of control structures for repetition. Fixed iteration is done with a for loop structure. This is the syntax. You use the keyword for, lowercase, and then you open the condition, and you begin with part 1, initializes your LCV or loop control variable. Part 2 sets the exit condition for the loop, which is really important because if you don't have an exit condition, what happens with the loop? It keeps going on and on forever, uses your resources. You either have to turn your computer on or off or control Q. You have to break out of that loop somehow if it's not programmed in. So this part 2 is really important so that you can exit the loop. Part 3 determines how the LCV changes, and this LCV from the introduction that I gave changed by an increment of 1. It can change by 2, it can change by multiples of numbers, and we'll see that in a minute. And here's an example of code for a for loop. Now remember that I want you guys to declare your loop control variable inside the condition. So int k equals 1. So now k has 1 in memory. Test the condition k less than or equal to 10, which in memory, if 1 is less than or equal to 10, you test that condition. If that condition is true, then you drop into the code and print. Or execute the block of code if it's more than one line after the for loop, and print Java is 10 times more fun. And then once that executes, come back into the back of the for loop, increment k in memory by 1. So now k is 2, and test, is 2 less than or equal to 10? True. Since it's true, I'm going to print this, go back into the loop, increment k. So now k is 3. Is 3 less than or equal to 10? True. As long as that's true, this is going to keep happening. Now, let's say that we have done this 11 times, and now k is 11. Now k is 11. Is 11 less than or equal to 10? Is our test. Since that is false now, we skip either the block or the single line that follows the for loop and continue on with the rest of the program execution. Okay, so let's learn how to trace. Okay, this is chapter progs 0514 from your chapter 5 chapter progs. And let's learn how to trace this program. The first thing you do is set up a table. The table has to include every single variable in your program. So you look through the program